So this is the beginning of Unit 6, and this is going to be Lesson 6.1. So Lesson 6.1, we're going to talk about, we're going to call this N-Sided, which seems a little weird, 6.1, the letter N, sided polygons. N stands for the number of sides, and it's going to be changing. So we could talk about a polygon, which is just a shape, a polygon that has four sides, a polygon that has 10 sides, a polygon that has 25 sides. So we're just going to put N there so that as we change it, it's not a huge deal. Okay? So again, we said that today is 5/16, 17. Okay. So here's the first question. It says, the sum of the degrees and any polygon can be determined by the number of triangles that can be drawn within the polygon. Complete the table below and look for a pattern to find the sum of degrees of any polygon. Woo, that's a lot. Okay? All that it's saying is, if I said you have a 15-sided figure and you wanted to know what all of those angles added up to be, you would figure out how many triangles there were in there first. And how many degrees does a triangle always add up to be? So if you had like two triangles in that shape, you would do 2 times 180. Okay?
Like rectangle would be
However many triangles you can draw times 180. So we'll do a couple examples. Let's look at this. In this first picture, which is called a triangle, we have 3 sides. How many triangles are there? This is kind of a silly question. 1, right? And so we did 1 times 180, basically. 1 times 180, which gives me 180. So all the angles in a triangle add up to be 180. We've already talked about that. Let's look at the second one. It's called a quadrilateral. It looks like a rectangle, but the official name is a quadrilateral, and quad means what? 4, right? Quadruplets, a quad runner, those are all 4 things, okay? Yep, so quad means 4. So there are 4 sides, and you can see here they've drawn from here to here is only how many triangles? 2 triangles. Okay, so couldn't you draw another one? Yeah, but now you've crossed these 2 lines and you're duplicating them now. Okay. Okay, so we have 4 sides, we have 2 triangles. So to figure out how much is inside a quadrilateral, I'm going to do 2 times 180, which is what? 360. So all the angles inside of a quadrilateral add up to be 360. So let's look in a pentagon. A pentagon has how many sides? 5 sides. How many triangles do you see that are drawn there in a pentagon? 3 sides. So then we're going to do 3 times 180. Three times 180. Brian says 540. Does anyone else get 540? Okay. So 540. That means that all of the angles inside a pentagon add up to be 540. Then we have a hexagon. How many sides is a hexagon? 6. And so how many triangles do you see there? 4, right? 1, 2, 3, 4. And each of those is 180, 180, 180, 180. That's why we do 4 times 180. Show them besides Brian. 720. Heptagon. What is a heptagon? How many sides is a heptagon? Anyone know? Hep is 7. And how many triangles can you draw in a heptagon?
I want to guess 5.
Why are you making that guess?
Because so far it's gone up by 1.
It has not gone up by 1.
Okay. The number of triangles.
You added one more corner, which would give you room for one more triangle.
Okay, look at what's happening. How do you go from 5 to 3? What do? Subtract 2. How do you go from 6 to 4?
Subtract 2.
Subtract 2. So every time the number of triangles is always 2 less than the number of sides. So how many triangles are there? There are going to be 5 triangles because every time you're subtracting 2. That's a property we need to remember. So then I do 5 times 180. 5 times 180. Katrinka says 900. Anyone agree with that?
Yep.
Okay. What's an octagon?
8.
8 sides. How many triangles do you think an octagon has, Carla?
What did you say?
How many triangles does an octagon have? 6, right? Because we're subtracting 2 every time. And then to figure out how many degrees inside of an octagon, 6 times 180, Tylea? 1,000 what? 1,080. What about a nonagon? That's a funny word. Nonagon, how many sides do you think that is? 9. Okay, so we've gone 1, 2, 3, 4, 5, 6, 7, 8, 9. A nonagon is 9. Nonagon, not a ninagon. So this one's going to have 7 triangles. 7 times 180, Braxton. 1620. And then we have a decagon. Deca is 10. 8 triangles. 8 times 180. What did you say? Oh, this should be 1260. Whoa, 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 whoa.
Yeah,
This.
nonagon should be-
They're on the back one. 12.6.
That's times 80.
And then
And we did
14.40.
Okay, does that look right?
Yes.
Okay. Does anybody know what an 11-sided figure is called? This might be a bonus question on a test. An 11-sided figure is called an undecagon. Undecagon is 11 sides.
It's 1,620.
A 12-sided figure is called a dodecagon.
I knew that one.
A 13-sided figure is called a 13gon. A 14-sided figure is called a 14gon.
I have a question.
Yes.
As the numbers go higher, is there eventually a point where it becomes a circle?
What do you think?
Yes.
I mean, I don't even know, like, because
So that's a great theoretical question. Is there a point at what time it's going to get so small that you actually are drawing a circle? You will always be able to infinitely draw a number of sides. You'll always be able to make it super smaller because if you were to zoom way into like 1,000%, 1,000,000%, you can still draw another round of sides. Interesting. Right. So here's the thing. After 12, all the sides just become whatever number of sides / gone. So like a 25-sided figure is called a 25 gone. A 50-sided figure is called a 50 gone. Really, really original, right? The only other one that's special is an icosagon. Icosagon. Anyone know, make a guess, how many sides is an icosagon? You might be wanting to write these down instead of just giggling over here because these are going to be extra credit questions. I think I've said that twice already. Icosagon is 20-sided. 20-sided figure is called an icosagon. None other ones have special names. Just the 20-sided figure. I don't know why.
Not even a
It's
hundred
special.
sided.
No. It's going to be 100 gone. I know, right? Original. Okay, so we can see a pattern here that's happening. If I want to find the sum of the interior angles, so if I wanted to find this column, if I wanted to find this column here, I took the number of triangles and I multiplied by 180, right? But how did I get the number of triangles? What did we always do? Subtract 2 from what? The number of sides. So this is what your formula looks like then. Your formula is going to say S for the sum. Okay, so S for the sum equals, whoa, n minus 2, where n is representing the number of sides. Okay? N is the number of sides minus 2, and then we multiplied by 180. Okay, we could agree with that. A regular polygon is one in which all sides are equal. You should know that. That's going to be a vocabulary. Regular polygon, all sides are equal. If all sides are equal, all angles are equal as well. If you see that word regular. If you wanted to find out how much each interior angle was, what do you think we need to do? Let's take a hexagon, for example. So we had a 6-sided figure, right? And we did, if we wanted to figure out the total inside, I would do 6 minus 2 times 180. What is that? We did it up above.
720.
720 was a hexagon. Did you guys agree with that? You see that back up on the top there? 720 is all the way inside. But if I wanted to figure out how much this angle, this angle, this angle, this angle, this angle is, what do I do with that 720?
Divided by 4.
Divide it by the number of angles that you have there, right? Or sides, they're going to be the same. You're going to take 720 and divide it by 6. Okay? So, I took this and divided it by 6. Would you guys agree with that? This gave me 720, and then I divided it by 6. So our formula to find the interior angle is n minus 2 times 180. That gives us the total. Then we're going to divide it by the number of angles. So again, the top gives us the total angle sum, divided by the number of angles. And that makes sense, right? How much it is total divided by how many angles. Right, if I wanted to distribute money to my class, I would figure out how much we have total and divide it by however many students, because that would be fair. Except for some of you may not get any. I'm just kidding. Yep, total sum divided by the number of angles. Okay, so let's look at a couple of examples here. Example 1 says, find the sum of the interior angles of a 15-gon. That means I want to find out how much total is the interior of a 15-gon. Okay, so if I wanted to find the sum, remember I need to take the number of triangles times 180. That's going to figure out how many angles, or what is the sum of the angles on the inside. So what is my in here, number 1? Whoa, whoa, whoa. What is the in value? 15 is the in value. Okay, so we're going to put 15 minus 2 times 180. And what is 15 minus 2? We know it is 13 times 180. Okay, so with your calculator, do 13 times 180. And I'm coming over to Monique. 13 times 180 in your calculator, please. 2,340? Does anyone else agree?
Yes.
2,340? Okay. So we'll say the sum is 2,340. All right, why don't you try number 2 on your own? Please set up your formula. John, what'd you get?
I got 3,420.
3,420. I would agree with that. Does anyone else agree with that? All right. Questions on number 1 or 2? Okay, let's look at number 4. Number 4 says, what is the measure of each interior angle of a regular 18gon? So we know we have 18 sides. Before I can figure out how much each angle is, what do we need to know? We need to know the total, right? Because before I can divide it into 18, I need to know what I'm dividing 18 into. So I'm going to do the same process that I was above. N minus 2 times 180. And then I'm going to divide it by my 18. So I have my 16 times 180, that's how many triangles there are, divided by 18 angles. Ben, what'd you get? 160. You didn't show anything? Is that what you said? Okay, well, you need to show your work because that's part of math. Each interior angle is 160 degrees. So now let's look at the exterior angles. We're going to skip what this says, and we're actually going to just try it out. Let's try out at this triangle here. If I wanted to know what all the exterior angles added up to be, how could I figure that out? First of all, I need to know how much the exterior angles are, right? What do we know about these two things right here? Hang on. What do I know about these two? They're 180, right? And if I already have 79, how can I figure out how much that one is up at the top? What could we do? Subtract from 180. Okay, let's do that. Let's do that all the way around. So for our exterior angles, we should have 101, 119, and 140. If I wanted to add all of them up together, let's go ahead and do that. It says the sum of the exterior angles. So let's add those three things together. And Hortensio, let me know what you find when you add all three of those outside angles together. $360. Anybody else get 360?
I have a question.
Yeah.
So with these, if we just add them all up and then times it by 2, then we get the same answer?
What do you mean add them all up and times them by 2?
Okay, so like 180, right? Like the triangle is 180.
Okay.
And 180 times 2 is 360. So if we added up all of the angles and just times it by 2, would we get the sum of the exterior angles?
So you're just multiplying the triangle times 2?
Yeah.
I'm not sure I understand your question.
I think it means that you add everything.
Like, okay, so if you add 79, 40, and 61, right?
Okay?
So what, it's supposed to equal 180?
Yes.
Okay.
Okay, times it by 2, will you get the sum of the exterior angles by doing that?
You got quite a bit.
Because it's 360.
Okay, so hold that thought for just a minute.
Okay.
Okay? Hold that thought. Let's try the hexagon one. Okay? So let's think about what Elvis asked, and then let's try the hexagon. So this time you have 6 exterior angles to look at. But you still know that together they make 180, right? Yes, Julia. Are you going to give me the answer?
No.
Okay.
I know that on triangles, when you have the outward line, angle, the sum of the two opposite angles equals that outline angle.
Yes, or
Is that way with hexagons as
No,
well?
just with your triangles. Okay, so once you find all your exterior angles, go ahead and add all 6 of them together. What part? Are you having trouble with? Oh, the magic part of it? No. Okay, what happens when we add all 6 of those together? Natasha? You get 360. Did anyone else get 360? Okay, so now Elvis, your question was if you add up all the inside ones and multiply by 2, you're going to be way over, depending on the shape, right? But what are we noticing about the exterior angles? Do you think it's just coincidence that they're both 360? Always, the exterior angles are going to equal 360. So our rule says the sum of the exterior angles of any polygon is always equal to 360 degrees. The sum of the exterior angles of any polygon is always 360 degrees. All right. We're going to do some practice problems on the next page. So we're not going to do the ones below. We're just going to do some practice problems on the next page.